Hi there, this is Thomas speaking from investmentexcel.com. In this session I will briefly introduce you to pricing of a non-callable and a callable cash flow structure. We will look at the present value, the set spread and the option adjusted spread. This session serves as an introduction to the more advanced pricing method techniques that we demonstrate in other sessions on mortgage bonds and callable mortgage bonds, models where we implement both a stochastic interest rate feature and a prepayment function feature. But in this session it will all be very simple, hopefully. This video and the Excel workbook and the underlying VBA programming codes are available on Investment Excel and spotafile.com. Let's start by looking at the cash flow. Needed info up here in the upper left corner. 5 cash flows. Expected payment of 20 at each cash flow, 5 years to maturity, so leaving 1 cash flow a year. We have a market price of 80 of this cash flow, given that there is no optionality in terms of leaving the borrower with a prepayment option. On the other hand, with this prepayment option, this optionality to prepay the notional amount earlier than required in the or scheduled in the initial cash flow structure is 75. If we price this cash flow on the government bond risk-free curve with zero coupon yields, it's 85. So obviously already now we can see that there is a discount on 80 here compared to 85. So obviously the borrower in this case is not the state, it's not the borrower behind the risk-free rates, and the 75 is another premium compared to the non-callable structure. So the 5 from 85 to 80 is a credit or liquidity risk premium. 75 compared to 80 is pure optionality premium, prepayment premium. Alright, let's look at the cash flow structure. And this is the non-callable structure. You see the 5 times $20 expected to be paid out according to the inputs. We have the government bond risk-free curve, all zero coupon yields. We have no spreads, and here we have the discount factor. So discount factor as usual being calculated by 1 divided by 1 plus the corresponding yield raised to the power of the majority, and here's the price for each cash flow in present value terms. Summing all present value terms gives 85, which is correct. It's also stated up here because that is exactly the risk-free pricing of the cash flow. So it can be interpreted as a price that investor will pay if he only requires the risk-free rate, i.e. he doesn't require any additional risk premium. But now let's start with the non-callable bond price. It's observed at 80 and the risk-free curve is priced as 85. So how much in percentage is this $5 worth? This we can find out by calculating backwards using the formula for the non-callable price. On the left hand we have the observed price, which is the sum of the discounted present values in each state, where the discount factor is 1 plus the zero coupon yield plus a constant spread. And in this case, with a non-callable cash flow, the set spread and the OAS spread is the same. The set spread is the total spread, total constant spread that you put on to all yields along the curve in the discounting. That is why there is no T on it. It's a constant spread. So what we have to do is to calculate backwards this constant, and we cannot solve it analytically, so we need to use a trial and error method to change this OAS until we reach a model price of 80. So basically we have to type in here a constant spread, which at some point will make this 80, and in that way we can see what is the required set spread for the investor. I will let Excel do the trial and error, and I do it up here. So I type in the 80, which is the market price. I type in the current present value on the risk-free curve, and it's 85 right here. And now I'll use the goal seek function. Go to data, what if analysis, goal seek. Then we set cell. This one I would like to have to 0. So 0 by changing the OS. So let's see. Okay, 2.29. So in other words, investor requires the risk-free rates plus an additional 2.29 or 229 basis points along the entire curve. So this is the risk premium for the non-callable bond. And what is in this risk premium? Basically everything but any optionality premium. So it could be credit, it could be liquidity, it could be many other things that you can think of, but primarily credit and liquidity. So this was the spread and pricing of the non-callable bond. Now what about the callable bond? We can do exactly the same thing, and I'll do it here. I observe the spot price. Oh, I should go down here first. Okay, down here I have the callable cash flow. Same structure all the way until here. We can see that there is a change in the cash flow. So the borrower prepays earlier all the way out, and this change of cash flow also changes the conditions of the pricing, but otherwise it's the same way of building it. So now I first start by pricing the set spread, and here in this case the set spread is not equivalent to the OAS spread. The set spread includes both a OAS spread, which by definition is this because it's the same credit risk and liquidity risk that we have. So the OAS is the same as on the non-callable bond. But I'll start by finding the total spread. So hopefully it's different from 2.29. And I will do it same way with the goal seek. Go to what if, goal seek, set cell, this one to 0 by changing the set spread. Okay. So now we are almost there. So the total spread that investor requires for buying into this cash flow structure with the optionality is 7.90. Again, it's the spread on top of the risk-free curve. And the way I found it was on this formula, where I just have both the option premium and OS, which is the sum of this is the set spread. So now, where we have the set spread and we have the OS spread, we can calculate the option premium. The option premium in dollars we know is 5, 80 minus 75, but converted to percentages, it's the difference between the set spread and the OS. Many people, they confuse the concept about the OS and the option premium. Many think that the OS is actually the set spread of a callable structure, but it is not. It's actually the same premium as that for an otherwise equivalent non-callable bond. And here, just to summarize, we have in total the risk-free curve, the zero coupon yields. On top of that, we have the OS spread. So the non-callable bond is priced on the gray one, and on top of the gray one there is another one when pricing the callable bond. So we have to add on the option premium. So all in all, we have the set spread represented by the yellow curve. Alright, that should more or less be it. This formula here is very popular normally for understanding callability. We say that the present value of the callable bond is equal to the non-callable minus the option, and that's exactly what we have here. So the callable bond, which is 75, is equal. Oh, sorry. The callable bond 80. 75 is equal to the non-callable bond minus the option. So 75. Alright, I think that was it. Thank you for listening.